Okay, let's have a look at STAWA set 19. And STAWA set 19 is about balancing half equations. To help us with this, we're given a nice little set of steps to follow through. Firstly, you write your reactant and product, and you work out what the formal charge of the the oxidation number of the thing which is changing. In this case, we're going from magnesium, which is a charge of 0 because it's elemental, through to its ion charge, the oxidation number equal to its ion charge, or its which is +2. Okay, so in this particular situation, now we understand what's going on. Magnesium 0 to +2. Good. We don't have to balance our atoms any further because 1 to 1, that's pretty good. And there are no oxygens required in this, nor are there any hydrogens that are required either. So steps 2, 3 and 4 pretty much can be ignored. They've been done essentially. Now all we need to do is add electrons so that the charge balance. 0 goes to +2. To make that +2 back equal to 0, on the side that the +2 is, we need to add -2, which is 2 electrons. Now we have a redox equation, half equation, which is balanced. When we take magnesium to magnesium 2+, we also release 2 electrons. And this is all that you need to do to have a balanced half equation. Okay, well and good. Most of these things continue along this particular vein throughout set 19. But then we get to extras for experts, and that's where things start to get interesting. So in this particular case, our question starts along the line. I've done this one before us, so I'm just going to get it out of there. The example in the book that we're looking at is the arsenite As033- forms the As043- arsenate ion. What's actually happening here is the oxygens are not actually changing their redox number. They're -2. They're not bound to fluorine or to anything else particularly interesting, such as a peroxide. They are just ordinary oxygens that are there. Arsenic here is the overall charge of this arsenite ion is 3-, and we've got -6 from the oxygen. So whatever the arsenic is, plus -6 will equal -3. This tells us that this arsenic must be in the +3 state. And that is going through to the arsenate. In other words, what's happening here, we've got 4 times -2 is -8. But that -8, together with the arsenic, produces -3. So let's add 3 onto both. Okay, we find that something plus -5 is equal to 0. So what happens? That means that the arsenic must be going to +5. That's our oxidation in this particular situation. Arsenic has an oxidation number of +3 here, and it's going to +5 there. Okay, so now we can start to look at sorting out our equation. We look to see, have we balanced the number of atoms? 1 arsenic to 1 arsenic of the element that's oxidized. That's beautiful. Now we have to get some more oxygen in there because we've got 3 oxygen here, 4 oxygen here. And our approach requires for us to get the oxygen from water. That's what we shall do. So we add a water in there, H2O. And we're going to, so it's all hunky-dory. So 1 plus 3, you'll notice equals 4. That's good. Everything's good. But Houston, we've introduced a problem for ourselves. Houston, we have a problem in that we have 2 hydrogens here. So what we need to do to deal with hydrogens is we balance hydrogen atoms by adding H+ ions. So if we've got 2 hydrogen atoms here, it means that using this approach we'll have 2 H+ ions over here. Very nice. We've we've just done that. That solved our problem with our number of hydrogen atoms. We now have 2 here, and we now have 2 here. That's pretty good, isn't it? Okay, so now all we have to do is sort out what happens to the electrons. Water plus arsenic in +3 goes to arsenic in the +5 plus 2 hydrogens. To go from +3 to +5 means that you also have to give up 2 electrons. So if we add 2 electrons on this side, what's actually happening is those 2 negative charges, those 2 negatives, together when added to the +5 charge of that gives us the +3 on the other side. And we can see that now we have a fully balanced redox equation, half equation at the moment. Water and arsenite becomes arsenate, produces 2 hydrogens and 2 electrons. And now this is a fully balanced redox half equation.